Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are starting with the third lecture of P3. And what is the third lecture all about? So lecture number 3 of P3, actually it's lecture number 2 of partial fractions. We already had one class of binomial. So this is partial fractions. And yes, it's P3. And it's part of algebra. It's the second subtopic, that is partial fraction. So now remember, I shared the PDF of binomial. We got started with binomial over here and the difference between P1 binomial, P3 binomial, the basic formula, the basic kind of working, and so on. That was the first thing. Let me remove this PDF. Then last time, we got started with partial fractions. So let me write over here. This one is about partial fractions. And in partial fractions, there are 4 cases that we deal with. So in partial fraction, the first case, that is, it's all about denominator. Denominator with dot, dot, dot. The first one was linear factors. The second one was denominator with quadratic factor. Of course, the linear can also be present. And it will be present. So this is technically lecture number 1 of partial fractions. Now we are starting with lecture number 2 of partial fraction. We will do case number 3, which is denominator with linear repeated factor. That is the first thing that I'll get started today. And the fourth case, that is an improper algebraic fraction, and then we decide the case. So now let's get started. Let's first review last time's work. Lecture number 1, partial fraction. If 2 fractions are given, we simplify and make it into a single fraction. That is O-level maths. Going back to the original, that is breaking up into its partial fractions. Case number 1, denominator with linear factors. This bracket, that's a linear factor. Power of x is 1, so it's linear. Whatever are the number of brackets, that many fractions we will have. The numerator of each fraction will be a constant. There is a linear expression downstairs. There should be a constant upstairs. Maximum power is 1 at the bottom. Maximum power is 0 at the top. Always make a habit of first factorizing the denominator. What is the strategy? Denominator decides the case. Write out the fractions. Solve for unknown constants. Write the final answer as partial fractions. For example, we took the same thing. There were 2 factors, 2 fractions. There is a plus sign. We take LCM. We equate the 2 fractions. The numerator equals the numerator. We solve this identity by choosing suitable values that will eliminate one constant at a time. That is the strategy. That is the strategy. We get the values of a and b, and the final answer is written as a fraction. Then we did a past paper question. And over here, I introduced the checklist. What is the checklist about? It's about the numerator. First, check if the degree of numerator. Degree means highest power, HP, highest power of numerator is lesser than highest power of denominator. It's a proper algebraic fraction, and that is the case over here. Highest power is 2, highest power after multiplication is 3. Yes, it's proper. Look at the denominator. Is it already factorized? Then decide the case. There are 3 linear factors. Therefore, we end up with 3 fractions. A multiplies with these 2. B multiplies with this and this. C multiplies with this and this. Again, apply the concept of identity. Choose suitable values. Find one constant at a time. If you have plugged in the constant, if you're left with the very last one, choose any value, any simple value. What could be simpler than 0? And find the remaining unknown constant. You can find in any order. Final answer. Then we introduce the second case, denominator with a quadratic factor. And this quadratic factor is not factorizable. 4 plus x squared, it's not factorizable. Let's say if in case of 4 plus x squared, if it was 4 minus x squared, that would be broken down as this, and that would become case number 1. So in P3, the name of the game is simplification. The name of the game is thinking about it. That first decide, then proceed. Do not proceed without thinking. So now, how do you do this? The There is a linear factor, there is a quadratic factor. The linear factor has a numerator of a constant. The quadratic factor has a numerator of a linear expression. We write it in a bracket so that we don't make any mistake while taking LCM. And then again, do the same working. Now there is a particular order. We would choose a value that will make this bracket 0. So two constants will disappear, leaving behind a, and we will be able to find a. Have a good look at it. I chose x is equals to -2. This becomes 0. This disappears. I found the value of a. Plug the value of a. Now choose the second best value, which is 0. It will eliminate b. A is already found, and now you will find c. Now, someone can ask this question, why did we not plug in 0 in the beginning? If I would have plugged 0 in the beginning, I would still be left with a and c, and that is of no use to us. So now you found out c, first a, then c, first a, then c. Now choose any value, and you'll find the value of b. Again, write the answer as fractions. Now, remember that this thing is possible, that when we talk about the numerator bx plus c, yes, you can find the value of b and c. Sometimes the value of b will come, but c will come out to be 0. So there is nothing wrong with your working. Sometimes the value of b will come out to be 0, and you'll be able to find the value of c. And of course, it's not possible that they both become 0. So that is out of box. And then you solve this, and then I focused on binomial expansion. So for binomial expansion, all you have to do is take everything in the numerator and then just do it like you would do in binomial. So if this question was given in binomial, you would apply the knowledge of binomial. You will make sure that the first term is 1. You will take common. This power applies to all. Simplify, and then you get this thing. Similarly, this thing for binomial expansion, just focus on this and then later multiply with 1 minus 2x as I have done so. So these are the first 3 terms, these are the first 3 terms, and you add it up. And then time was running short for my second class, so I did not actually add it up. But of course, it's 100% correct. And this is the answer that you get. That was the end of lecture number 1. So all this talk for around 9-10 minutes, that is reviewing the basics. And that is what I'm good at. So now let's get started with partial fractions, lecture number 2. And now maybe you can get something like this. If x plus 1 is a linear factor and x squared plus 1 is a quadratic factor, then what is this? X plus 1 whole square, we would treat it as a linear repeated factor. Now focus on each term. Over here, linear factor, the power of x is 1. That's what makes it linear. Over here, the power of x is 2, not the bracket. The power of x is 2. That's what makes it quadratic. Over here, there is a 2 outside. That is linear inside. So this is linear and this is repeated factor. So that is the classification. And naturally, in the quadratic thing, it's not factorizable. So now, if I look at this question, first, the checklist. The checklist is this thing, which is the green one, that it's linear on the inside and there is 2 on the outside. Therefore, first of all, this is linear repeated factor. Second thing, which should be actually the first one, the power of x is 2. After multiplication, the power of x in the denominator is 3. So it's a quadratic upstairs. It's a cubic downstairs. So yes, it's a proper algebraic fraction. And that brings us to case number 3. that is denominator with linear repeated factor. So this is a denominator with linear repeated factor. How would I work it out? So I'll work it out like this: 2x squared plus 7x plus 8, 2x squared plus 7x plus 8. This is being divided by, what is the denominator? 1 plus x, 2 plus x, the whole thing square. 1 plus x, and this is 2 plus x, the whole thing square. So I'll make it identical to 1 plus x goes down, 2 plus x goes down with the power of 1, and this is 2 plus x goes down with the power of 2. That's how we write it. There are positive signs in between. There is a constant a, there is a constant b, there is a constant c. Now, few things to consider. Those few things are, let me just highlight this, that when we are talking about linear repeated case, all numerators are constants. That is the first thing that you need to take care of. Second thing that you need to take care of is that someone can ask this question, that why not expand 2 plus x whole square and make it second 2 plus x the whole thing square and make it 4 plus 4x plus x square, a quadratic. So now this cannot be done. This is not advisable because we are ordered to factorize the denominator rather than complexify. So factorize the denominator first. So this goes against that rule. Is this all good, all clear? So now let's get started with this. Let's get started with the working. So therefore, we have this thing, which is 2x squared plus 7x plus 8. And there is this line over here. And I'm writing it down again. This is 1 plus x. This is 2 plus x whole square. This is identical to 1 plus x, 2 plus x power 1. And this is 2 plus x power 2. That's how it's written. Positive sign, and then draw this line. And then the LCM would be the same. So this is 1 plus x, and this is 2 plus x, the whole thing square. This is 2x power 1. This is 2x power 2. So the LCM of these two is this. And these two are different. Therefore, the LCM is this. Of course, it would match with this. So now let me go to my WhatsApp. And to that thing, we are looking at something. Let me go over here. And this is the red one. So is the case 3 LCM part. Is this all good, all clear? अच्छा जी, just double check. Okay जी. So now it's not over yet. The LCM part is done. Let me write the numerator. This is A, this is B, this is C. And let me draw a longer line over here, like this. And this is identical to. So now A gets multiplied with 2 plus x whole square. C gets multiplied with 1 plus x. Technically, compare this with this. This is the uncommon one, so A gets multiplied with that. Compare this with the LCM. This is the uncommon one. It gets multiplied. And this B right over here, it will multiply with 1 plus x. That's the first thing. And it's not over yet. B multiplying with 1 plus x, and there should be 1 at the bracket. Which bracket is that? This is 2 plus x raised to power of 1. This is 2 plus x raised to power of 2. If I divide this with this, I'm left with 2 plus x. So it will also multiply by 2 plus x. All good, all clear. So now people, let's solve this question. Now both fractions are identical. Let's equate the numerators. So this is 2x squared plus 7x plus 8 is identical to a times 2 plus x whole square, b times 1 plus x into 2 plus x, and c times 1 plus x. Now let's solve for a, b, and c. I've already pasted it over here. Let's get started. If I focus on these two brackets, I'll choose let x is equals to -1. So therefore, 2 into -1 square, 7 into -1 plus 8, that is 2 minus 7 plus 8, 10 minus 7 is 3. So now a into 2 plus -1 whole square, that is 2 minus 1 is 1, 1 square is 1, that is a, therefore a comes out to be 3. So a comes out to be 3. Let me write a is equals to 3 over here. Let me choose any other value. Let me focus on this. Let me focus on this. Let x is equals to -2. So 2 into -2 square plus 7 into -2 plus 8. That's 2 into 4 is 8 minus 14 plus 8. 16 minus 14 is 2. So now this is 3 into 0. That thing becomes 0. This is 0, this is 0, this is c into 1 plus -2. This is minus c is equals to 2, minus c is equals to 2. Therefore, c comes out to be -2. Therefore, c comes out to be -2. Now, in order to find b, choose any other suitable value. Let x is equals to 0. So 8 equals to 3 into 2 square, which is 4. This is b into 1 into 2, and this is -2 into 1. So this is 12, this is -2, this is 2b, this is 8. So 8 plus 2 is 10, 10 minus 12 is -2 is 2b, therefore b comes out to be -1. So let me add a page over here. So the final answer is this thing, the three fractions. Let me copy this thing and let me paste the values. So now over here, copy, and let's paste over here. And a is coming out to be 4. So a is coming out to, I think, 3. B is coming out to be -2. C is coming out to be -2. And last but not the least, that is B is coming out to be -1. So let's pause here for a moment so that you people can copy it. And let me share a question with you so that you can also try this out. So now people, let's look at this question. This was the question. I asked you to try it as a classwork. ठीक है ना? तो ये हमने आपको classwork के तौर पे दिया था. So now, what is this question all about? First, double check whether it's a proper fraction. Highest power is 2, highest power is 3. Yes, it's a proper algebraic fraction. So the first checklist is done. The second checklist is which case. So there is a square on the outside. So therefore, this is linear repeated case, which is case number 3. Express fx in partial fractions, hence obtain the expansion. That means the binomial expansion of fx in ascending powers of x. Whenever we expand 1 plus b raised to power of n, naturally it's in ascending powers of x up to and including the term in x square. Now let's go very slowly on this. First thing first, since there is a square over here, it will be written once like this and secondly like this, and both constants, both numerator will be constant. This is a simple linear factor, so there is a at the top. The second step is about taking LCM. Naturally, the LCM has to be this. So now over here, this x plus 3 goes down, and out of these two, this is like 2 and 2 square. So the LCM is 4. This is like 3 and 3 square. The LCM will be 9. So this is x minus 1 power 1, x minus 1 power 2. So the LCM is x minus 1 whole square. Again, emphasizing on this because that's what algebra is all about. There is nothing special fancy about it. This a, since it has x plus 3, it will multiply with x minus 1 whole square. C, it has x minus 1 whole square. It will multiply with x plus 3. Okay. And B will multiply with this thing, which is x plus 3. And also, this is x minus 1 power 1. This is x minus 1 whole square. So x minus 1, it will multiply with that. Now, focus on this thing. That is what we are focusing on, this thing over here. There are three unknown constants, A, B, and C, and then find them in any order that you feel fit. So now over here, let me do this part right in front of you again. So let me start with the value x is equals to 1. So let x is equals to 1. Therefore, 10 into 1 minus 2 into 1 square. That is 10 minus 2, which is 8, equal sign, equal sign, equal sign. This disappears, this disappears. We'll be able to find C into 1 plus 3. That is C into 4. That is 4C. Therefore, C comes out to be 2. That's a clear-cut number. So therefore, we found the value of C, and C is coming out to be 2. C is coming out to be 2. Now let me choose another value. This time I'll choose negative 3 because x plus 3 will disappear. So let x is equals to negative 3. So 10 into negative 3 minus 2 into negative 3 square, that is negative 30. 2 into 9 is 18, minus 30 minus 18 is negative 48. And now I have a, which is negative 3, negative 1 whole square, which is a into 16, which is 16a. 4 square is 16. So therefore, a comes out to be negative 4, 16 threes. So 16 threes are negative 4, and there is negative 3. So I found the value of A, I found the value of C. Now let me choose any other suitable value. What could be more suitable than 0? So 0 minus 0 is identical to minus 3 into negative 1 square, B into 3 into negative 1, and this is 2 into 3. This is 0, this is negative 3, this is negative 3b, this is plus 6. So 6 minus 3, and over here, let me do my correction. Once you plug in the value, it becomes equal for that value. So now this is 0, 6 minus 3 is 3, 3 minus 3b. So therefore 3b is equals to 3, therefore b comes out to be 1. And now let's write down the final answer. So there were three fractions, and let me write those fractions over here. The numerator was a, b, and c. And then a was the numerator of x plus 3, b was x minus 1, c was x minus 1 whole square. B is coming out to be 1. C is coming out to be 2. C is coming out to be 2. And then we have one more, which is C is coming out to be 2, and A is coming out to be negative 3. And C is coming out to be 2, and A is coming out to be negative 3. Okay, so now let me just correction. So C came out to be 2. Now let's double check. So now over here, the first one, negative 3 over x plus 3. This is correct. 1 over x minus 1, 1 over x minus 1, that is also correct. And then the last one, that is 2 over x minus 1 whole square, 2 over x minus 1 whole square, that's also correct. So 5 marks are obtained over here with a star. So that is how these three constants are found. Now we start with the second part. This is part 1 done. Now let's focus on the second part. It says, hence obtain the expansion on fx in ascending powers. And it uses the word hence. That means use the partial fractions. So there is the partial fraction. Let's focus on the blue one. Now on the blue one, when we focus, so this is negative 3. And this is 3 plus x or x plus 3 raised to power of negative 1. Now we want the first term to be 1, so I took 3 common out. So what am I left on the inside? 1 plus x over 3, the whole thing raised to power of negative 1. So now this negative 1 is applicable on this. It's applicable on the bracket. 3 raised to power of negative 1 is 1/3. And these are the first three terms. This is 1, this is n, b, and power 1 over 1 factorial. No need to write it. N minus 1, b raised to power of 2 divided by 2 factorial. After the simplification, this is what you are getting. So now this thing over here is this thing. The blue thing, that's right over here. Now keep these three terms separately. Let's move to the second bracket, the green one. So now the green one over here, that is 1 over x minus 1. This is 1 over x minus 1. And this is x minus 1 raised to power of negative 1. I wrote it negative 1 first, and then x raised to power of negative 1, negative 1, 1 minus x raised to power of negative 1. So now this negative 1 is applicable on this, applicable on this. Negative 1 raised to power of negative 1 is 1 over negative 1 power 1, which is negative 1. Which is negative 1 over here. Right now, this is negative 1. And then on the inside, the first term, the second term, the third term, take care of the positive, negative. And this is what you are getting right over here. That is the second expansion. Now comes the third expansion. Okay? So now comes the third expansion, which is 2 over this thing, which is 2 over x minus 1 whole square. That is 2x minus 1 raised to power of negative 2 minus 1 plus x raised to power of negative 2. Again, this negative 2 is applicable on negative 1 and on this, because I took negative 1 common. Negative 1 whole square, that is positive. So this is 2 into 1, that's positive. First term, second term, third term. Simplification, this is what you are getting right over here. And then you add all of them. So you add this first one, then the second one, then the third one. The constants cancel out. We get a 0. 10 over 3x, 44 over 9. This is working for myself. And double check 10 over 3x, 44 over 9, x squared. So here we would stop lecture number 2 of partial fractions. So now case number 2. Case number 3 is done and dusted. In the first lecture, we did case 1 and case 2. So this is lecture 1. This is lecture 2. We again revised binomial also, so that those people who are watching it for the first time, they have a very good idea about it. Okay, so take care everyone. See you in the next class.